Guys, we're going to do page 163, activity 3.2, question 3, nah? Okay, which is a question on any transformers. Okay, question reads as follows. A 6,600 500 volt single phase transformer supplies 200 amps to a load operating at a power factor of 0.8 watt lagging. Nah? We are given a transformer ratio. We are given that the transformer supplies. Okay, it is not drawing, it is what? Supplying I-bar, no? Huh? I2, yes, supply. A supply current. A supply at the secondary side. We draw from the primary side, no? Okay. Then it operates again. It supply a load that is operating at a power factor of 0.8 lagging. Now, the transformer details are as follows. We are given the primary resistance, the secondary resistance, the primary leakage reactance, the secondary leakage reactance. Then they ask us to calculate the equivalent impedance referred to the what? Referred to the primary. Nah? They want us to calculate ubani. Okay. In order for me to do that, I need to know the equivalent resistance referred to the primary and the equivalent what? Reactance referred to the primary. Nah? So we said most equivalent resistance referred to the primary is R1 plus R2 times what? Transformer ratio squared. Nah? Okay. So we are given a primary resistance. What is it again? 3. Then secondary resistance 0.01. Then the transformer ratio, which is 6,600 over 500. Remember, when you are calculating, referring to the what? Secondary side, né? You do the inverse of the what? Of the transformer ratio, né? R2 plus what? R1, then 1 over transformer ratio. When we want to calculate, referring to the what? Secondary. Okay. What is the equivalent resistance? 4,742 ohms. That is the equivalent what? Resistance. Now I need to find the equivalent what? Reactance referred to the primary and transformer ratio squared. Nah? What is the primary leakage reactance? 7. Okay. Then secondary 0.4. Then obviously transformer ratio is still the same, 6,600 over 500 squared. What is the equivalent? 76, 76, 69 like this, nah? Oh, okay, 696 ohms. That is the equivalent what? Reactance. Now I can calculate the equivalent impedance. There are two formulas, nah? There's one there, no? Pythagoras theorem. Okay, is one complex notation, which is k plus j x e. You choose which one you want to use, but you can quickly use the Pythagoras theorem because it will just give us the answer quickly, which is 4,742 squared plus 76,696 squared. What is the impedance?
76.
Sorry?
76.
76,842. Ana? Usebenzise le complex. Answer ke, you take the polar answer, ne? The polar answer le, ne? Okay, no, it's fine. But eyona answer yiphi yile i-angle nje iyabonisa uba okay i-value i-angle yayo angle ethile ungayifaka nayo i-angle ngubani? 86,462. Okay, right still. Just that this one shows also what? The angle, ne? Okay, put 0,4. Okay. Otherwise, they born out, ne? Okay. I'll skip question bunny. Question 3.2, ne? Okay. Then le enye ifuna ntoni? Percentage regulation, ne? Okay, because with i-values zethu i-percentage regulation xa i-values zethu ziyi-in percentage form zibala ne? Ithe what? Lagging, ne? Lagging bani? Positive, ne? Okay, cos okay, but sorry, but our values are not in what? Our values, which is the equivalent resistance, equivalent reactance, are not in what? Percentage form, na? So you're gonna use Lena. Okay. So it's in a 7 second primary, na? So we're gonna say I what? I1, Anna. Then R equivalent 1 sine, cosine theta, because it's what? It is a lagging power factor, we put a plus. Okay. Then over what? V1. Yeah, because I'm using the primary side, you notice that I don't have the current on the what? Primary side. I have what? I2. So I'm going to use transformer ratio V1 over E2 is equals to I2 over I1. Yeah? Okay. For I1 will be, I'm making I1 subject of the formula, that will be 500 over 6,600 times 1 times 2 times 200 the current, ne? Okay. 200. What is I1? 15,152 amps. Now I can go and substitute for any percentage regulation, ne? which is 15,152. Then equivalent resistance, that is 4,742. What is the cos of the angle, guys? Or cos of the angle, money? Goes 0, cosine, sorry. Cosine goes 0,8 and it's a mos. It has 0,8 what? Lagging. But I need to find the sine of the angle. And the cos of the angle is what? 0,8. And then what is the angle? Ne? What is the angle? It will be cos 0,8. What will be the angle? 36,8 what? 7. What is the sine of 36,87? 0,6. So I'm gonna put 0,6 where there is what? Sine. Plus the equivalent reactance is 76,696, then 0,6 over the primary voltage, which is 6,600 times 100%. So what will be my percentage regulation? Guys, after test 2, we are going to immediately go to chapter 4. Don't worry about the things that we leave behind. Huh? We'll go back to them because I want us to cover the entire textbook. No, we'll jump chapter 4. Because chapter 4, I want us to do it with chapter 2, percent the 3-phase loads. It was the same thing, and it's very simple, that chapter. Related what you call instruments, measurements of power in 3-phase system. We're going to do that when we are dealing with 3-phase loads. Leben City, they should have combined that chapter. They should have combined it with chapter 2 and the power 3-phase loads. We'll go to chapter, after test, we'll go to alternating current machines. Okay, which is something we didn't have much time to cover the last trimester. Okay, what is the answer? It's already in percent, now. 1,568%. Nah? Then the next question wants us to find what? Terminal voltage. Nah? A terminal voltage is V2, E2, open brackets, 1 minus per unit regulation. Okay. Well, E2 is what? 6,600, which is the induced EMF in the secondary. 1 minus, what is per unit regulation? What is this value divided by 100? Okay, so and cover right, calculate. Calculate it in here. So, kasi pa just 11,4. Yeah. Okay. Ngithathe le value ninike yona. So we should be getting 11,4 now. So 11,4 divided by 100. What is the output terminal voltage? Sorry? Remember, 11,4 medicine divide 100. Ibe per unit what? Regulation, no? What is the answer? Guys, Pajana, it's time. P? Oh, sorry. E2. Thank you. E2 is what? 500 or 6,600 in primary voltage. Thank you, na? 442, comma 825 volts. Okay. That is our secondary terminal voltage.